today we will cover the framework called Warp. And Warp is dependent or is built up on the runtime called Tokio. So I guess there are more runtimes in the Rust world, but I think the two most famous ones are Async, STD, and Tokio. And my guess is in the Rust shop you might take on in the next few months or half a year. I think that Tokio is sort of like the standard now. I think that many companies chose Tokio in the past, and this might change, and they might choose this runtime here. So, but for now, I will cover Warp, which is based on Tokio, and and Warp just runs on Tokio. So to get started, I created basically an empty like a new project. I called it live code December, and if you go into it, you will see the basic bare bones. And for every project to get started, you need to add a few dependencies, and for Warp, that's basically the framework itself, and it's the runtime. And no matter which framework you choose, you basically go to the GitHub page and check which requirements they have. Each web framework you probably have to implement or add the runtime as well. And after you've done this, we just copy paste just to see if we've done everything in the right way. So here is basically the how you say it? Well, the starter example. And what Warp is using in the background for its HTTP implementation is a crate called Hyper, which brings the HTTP server up in the background. So behind the Warp serve here, is actually here we go. Is actually the HTTP server called Hyper, and the function called run is returning a future. That's the reason why we need a runtime, so we can have an asynchronous function and await the future, so it's getting actively polled from the runtime, and we have a simple first route, and we will go into the Warp filter systems as well. So here we have our, let's see if we are still in there, live code. I think I changed it. Here we go. So we start the server, and we can basically curl the first example. And what we have here is we create a path called hello, and we expect a parameter which is a string. So we have a path which is hello, and then we can pass a string which could be my name or your name. And once the compiling is done, we can see, we can see here the server is up and running. We send a GET request and we get back a hello Bastian. And why we get this back is because on the serve we pass our first path, and we take the string and we print. So the format is basically like a macro, just like print ln. but it's but it's oftentimes like used to return a string. And here, because we use a Rust or like a Warp filter here, and how Warp filters work is they expect a certain return type. In this case, we can return a string, and Warp then like knows how to handle this string. And we take the string parameter and we give it a name called name, and we basically return this string here. If we want this to change, let's say hi 2, and you see the first little downside here. Oops. If you come from a language like Node.js, now the server would like recompile in the background here. We have to stop and we have to recompile the application and start from fresh, which takes like not as long as in the beginning, but we curl this again and you see here's our changed string. Let's say hi 2, it's a bit weirdly formatted. But that's basically the first 10 minutes into your Rust journey. Let's say you join a company and you want to find out, or maybe you find out the framework they are using in production, and I would always recommend to check out the GitHub page, create your own little like example project and play around just with the basics and try to change a few things. And from here, like that's not very scalable, like the whole thing, but let's try to form an API which we could use sort of in production. I say sort of because we probably don't cover in the next 50 minutes each of the edge cases like you might face, but to give it like a bit of a structure. And how Warp is working, it's using like a filter system. Like it's nothing you need to know from the start. It's more like it figured out like this is the way they want to go, and their base idea behind the whole thing is its filters, which means an incoming request is getting passed into here. So like you start a server, you open up the port, and once like a request comes to the Linux socket on this port, this HTTP request arrives, and from there like Warp is sending the HTTP request to a set of filters to either add a few data points to figure out like the path, and once it matches a path, it calls the underlying function. So this here is basically a shortcut. This macro here is a shortcut. And now let's see if I can find. So let's see, let's go to the docs. You have the filter system, and you have path, and you have the shortcut here, like the macro path, but you can also do path get or path post put. I just have to figure out under which this is. Filters, no. Let's say post. Oh yeah, it's just under here. It's not path. It's you have, for example, path get. And then I have to check of how it actually works. So you have path get, and then you say and let's remove these pieces here. and then you basically open up a path. So you would have here path, and let's say the path is hello, and then you would say path end, and then you would pass the route handler here. So we can call this function hello, and hello is not there yet. So we create an async function called hello. It doesn't take much. And now the question is, what should we return here? And I have to say here, the docs are not super simple. My way to go would be to go to the examples and see what the route handler actually has to return. And I think you will see an example. I don't know if you will see an example. At least for me, it's good to know what actually is the signature. So you would return a result, and you either have a reply or a rejection. This is how the route handler signature looks like. And where's the problem? Yeah, right. So we can say here this is not right. We need to okay it. And we need to return a warp reply. I think this is it. No, it's not okay enough. Okay. So let's see if this works. Now you can see that this is quite a more of a complex solution. It's longer, and now we are missing a feature which is pathing a query parameter. And in case you have any question, feel free to ask them in the chat. So we can start this again. We send a curl and we get back a hello world. So that's great, but we actually wanted to pass a name too. And how this can work, the longer version, is you can get, is it param? And we have to check here again, was it path param? Yep. And I think you can do string, probably not like this. Maybe like this. Always have a little cheat sheet. Ah, yeah, right, of course. Why doesn't this work? Path param string. Oh, that's okay. Oh, okay, it didn't save yet. So now Warp tells us that we added like a parameter to the function, but the function doesn't like expect one yet. So here, and this is why I find like the base example like a bit like misleading for your future like endeavors with Warp. Here you can see like the filter system in full force. Like we pass in like the route. So, and each HTTP request which arrives at the hyper HTTP server in the background, it will send through the Warp filters, and it checks is this a GET request? Check, is it on the right path? So here on the curl we send to /hello. So check, and now this filter like expects a parameter. So if we would send the same curl, we would get like a 404 back, and then the path is ending. So like we basically constructed the path like what we expect from this API call here, and then we pass the request onto our route handler. And here we see that we need to pass a parameter, which is a string. And now it says it's basically like not used, but we can do this here now again and say we pass param, and now it's used. Then we save it, we restart our server, and now we can see what happens if we send the same like one again. We see like nothing happens. We get like nothing back. And on the left side here on the server, we don't have logging or debugging. So now we have no idea like what was the answer of this call. And we can say like the parameter is Bastian. Does this work? Yeah, and this works, and we get back hello Bastian. But what happens if we like want to pass actually like a query and not a parameter? So we can say query, and here let's see if this works. If we do this, and we have to restart the server again. Invalid query string. Beautiful. So somehow this doesn't just work. And for this we can again check in Warp and see if it tells us something helpful. For example, here like it's using a hash map for the query, but it doesn't seem to do this. So like you can see that like that's not really like a query string. Like you can say name is Bastian, and let's see what happens now. Same thing, because string is not the right type for these types of like requests. And for this we can use a hash map. So we can use the hash map from the standard library collections, and we can say we expect a hash map with string and string. And the beauty of Rust is now that it tells us, hey, that's the wrong type here. So here, like we can't make a mistake. We have to expect a hash map here. And obviously we can't print it out like this because we didn't implement like a display trait for the hash map. So we can use the debug trait and print out our query parameters. We can try this again now. And now we get back our query parameters. So this is like the difference between like a parameter or like a query string in Warp, and this is how you would basically create APIs. Yeah, like maybe you have a product and you want to query like the product name.